Hey, Jairaj. What's up? How are you?
Hey, Prasanna. Good. How's it going?
So it's 9 in the morning for me, Sunday, typical working hours for us. So let's get to the bottom of this. So this is state of the art. I want to understand from you how Claude Code and Antigravity compare. I know recently you spent a lot of time testing both and you created a module from scratch using Claude and then using Antigravity. So you have a really good sense of what is the comparison between these two agentic systems. And of course, you are a extremely solid developer that I respect a lot. So I thought I will get you on a call and ask you to walk me through the difference between these two systems. And maybe we can share it with the world. So that's the goal. So thanks for joining. Give me a high level, right? What were you trying to build using these two systems? And how much time it took to build? And what is the...
Let me start with the problem statement. What exactly I was trying to solve this. I wanted to build a Python-based job runner. So it's more like a data sync layer. I really wanted to build a large-scale data syncing layer for HubSpot. So the primary goal is I need to take some of the larger objects, I need to export and then put a bunch of ETL on top of it. And then I need to upload things to S3. So the major bottleneck I was facing with Lambda today is like 10 GB was not sufficient. Existing code base was on Node.js. There are a bunch of problems. So I really wanted to rewrite the whole data syncing module, the bulk syncing module in Python with proper parallel processing, with efficient memory usage, not hitting a memory bottleneck or any other bottlenecks. And it has to be like super smooth all the way from downloading, parsing, verifying, and uploading. So this is the high level problem statement actually I was trying to solve by just fully leverage AI. I didn't want to write any code manually. Let's go and give a shot, spend time, go deeper on these models, and then figure out like, is it really gonna help me building a production grade application, or is it a hype? Or is it something like, okay, people are doing vibe code, I'm just cool, building cool stuff, but is it really good for production grade application? That's my primary agenda. In fact, I took it personally and then spent pretty much almost like last weekend, close to 20-25 hours, like continuous stretch I spent, and then figured out a bunch of stuff in Claude Code. And this weekend, I tried to replicate the same thing after Antigravity release. So I spent a good amount of time in Antigravity and then try to replicate the same just to compare which is good, where it is good, which is bad, all those apple to apple comparison.
Good. And tell me about time saved, because that's kind of the most important impact. How much time you think you saved using Claude Code, building this module? And how much time if you had used Antigravity also to build this in production? What is the impact?
Yeah. To verify that impact, I went and asked my engineers. I pulled them in a call and then demonstrate the application all the way from different modules, authentication, orchestration, processing, whatnot, everything. For a kind of a junior engineer who has 1 to 2 years of experience, they agreed it will take easily 1.5 weeks to 2 weeks to ship a production grade application like this. And for a intermediate level engineer to a senior engineer, easily somewhere between 3 to 5 days. End to end, building from scratch, checking all the different edge cases, make sure it is purely a parallel processing, disk operation, not hitting the memory. There are a bunch of test cases you need to test, make sure it works for zip file, normal CSV, all this parsing, validating the CSV, whatnot. In order to cover equal amount of best practices, for almost a senior engineer, easily 3 to 5 days, wherein which for a junior engineer is close to 1.5 weeks to 2 weeks of time. That is what I got from real engineers. I asked them like, hey, what do you think? And for me, it took, again, back and forth conversation with AI. It's around 20 hours of time. The base foundation was ready within 5 hours. The first initial version. And on top of that, all this good to have, nice to have optimization and everything, back and forth testing, it took close to somewhere around 15 to 20 hours of time.
One thing I have to say, 3 to 5 days for this without AI seems like way too little. I think you're talking about in Jairaj team days. There are two different worlds. Regular team days and Jairaj team days. Jairaj team days is 3 years productive. But see, I've done this for a living, building products. And this is more like 4 weeks. That's what people take. And you are saying with AI, you is 20 hours. Okay, that's a large productivity impact jump. And would you say the same thing is for Antigravity also? I know you tested it later after this went to production. Would it be similar kind of impact?
The initial impression was good, though a little bit of a glitches I encountered with Antigravity, with models, some of the basic mistakes and etc. I just want to emphasize one thing here, right? As an engineer, we should adapt to the AI. We shouldn't use AI as a search engine or a search system where like, oh, I have something in my mind, I'll throw you, you have to give me an answer. If you're expecting an answer from the system like Claude Code or Antigravity, I think we will be end up with disappointment.
In this case, when you say answer, you mean the code ready to ship, you're saying that's not what you should expect, but
No.
more like you should work with the system, you should iterate.
Exactly.
It's an iterative step-by-step process before you go to production. And we'll talk about that process that you went through in this course. So that's the high-level feedback. What do you say? Hey, if you're able to do that, then you can get to the finish line, but you need patience and you need to work with the AI system. But more importantly, the impact you are saying is similar between both Claude and Antigravity. Let's break this down, right? Walk me through step by step, if possible, share your screen, starting with the prompt that you would use in both systems. And I want to look at the user experience. What are the different steps? How does it happen? And where is this 20 hours going? Let's talk about that, right? Since AI is writing every line of code, so the obvious question is, why do you need 20 hours to build this? Why can't you just prompt it a few times and it'll just give you the code? Because I'm sure from the time you prompt before the AI responds with code, that is not few hours or even few minutes. That's probably 2 minutes. But given that, where is the 20 hours going and why it's essential to spend that kind of time or even set an expectation that this is not instant. You got to spend that kind of time to be able to get to the right outcome. And this is state of the art. This is literally the best kind of model and agentic system we are talking about in November 2025. So this is demystifying all the hype. This is the reality. So let's show some screens and let's walk through.
Yeah, sure. Perfect. Are you seeing a design doc.txt? This is my prompt.
Great. Again, we are looking at a system that can sync data between HubSpot and TerraView. That's what you intend to build. Again, obviously we had a system, but you wanted to completely rewrite it. You knew what are the challenges with the current system. And this is the prompt. Okay. How many lines is the prompt? Scroll through that. It's more like 14 paragraphs of prompt. Okay. That is good. And high level, what are you instructing in this prompt?
I want this has to be in Python. I'm going to run this in either in Lambda or EC2. The code has to pick up certain jobs from so in the Mongo collection. And then you have to check for certain threshold, like beyond 500K rows, you have to process in certain way. If it is less than 500K rows, you have to process in some other way. And how you will pull the access token and connect with HubSpot. What if the access token expires? How you should do the refresh. And then what is the different file system you will get? Sometime you might get .zip, sometime direct CSV. If it did .zip, then you need to extract it and then upload the main file to S3 and then just process that, unzip it and chunk it, because I don't want to upload all my 10 GB of CSV in one go to S3. I need multi-part upload. I need chunking, because if I'm in a Lambda, like for example, something gonna go wrong or whatever, I just want to push as much as file possible. I don't want to crash everything. So I need proper chunking, because without chunking, my memory might be a bottleneck. Then the multi-part upload and a bunch of status, like when you reading, what will be the status? After you upload, what will be the status to be updated in Mongo? And the core part is, it has to be memory efficient. It has to be chunking. It should be streaming without hitting all these bottlenecks. And of course, it should be parallel as much as possible. This is a high level thing I covered in the prompt.
Okay, that's good. Now, so basically what you're trying to do is you're writing code, but you're giving a lot of prompt on optimization, right? That's the goal here, because you already have this running in the system, but you want a more optimized system and you decided it's just better to rewrite it. You already have it in TypeScript. You want to do it in Python. And so you thought, okay, let's use Claude Code to rewrite the whole thing in Python. Okay, that's great.
Now, pretty much high level, good requirement. I would say it's not just a prompt, it's more like a requirement.
It's very good, very clean requirement. That's good. And you use the same thing in Claude and Antigravity, right? Exactly the same requirement.
Same thing.
Now, just talk to me high level for a minute. What are the steps happens before you get to the final piece of code that you push to productions? Basically, I'm asking you to give me a high level overview of the 20 hours, and then we will go through in detail.
Okay, perfect. So my first input to all these models, okay, this is my requirement. Don't start generating code. Don't go to the implementation immediately. Just give me your understanding, what you understood from this. And then give me a proper detailed architecture and then implementation plan. Like a very detailed architecture document, how you will go and address this problem statement. So that is what the first thing I'll spend. And that's where good amount of time, at least 25 to 30 minutes of time, because it's very lengthy. I need to really go through line by line what it is thinking, what are the different models it has come up with. In fact, I could quickly show this. It just came up with a very detailed architecture document with almost 414 lines or even more lines of architecture document. I went through all this file structure and then what are the different responsibility of each file, different files it's going to write. And pretty much it just put very detailed flow diagram, memory constraints.
This is Claude Code or Antigravity?
This is Claude Code.
Got it. Okay.
I'll show you the Antigravity, but pretty similar. So
the first thing the system gives you is design docs in many ways. And design doc tells you what is the folder structure of the code, how many files, what are the different modules in this code, which module is there in which file, and what are the responsibilities of each module. So it just splits the whole thing, just gives you a solid plan, very detailed.
Yep.
And it's so detailed, 400 lines. Your job here is to review this and then approve, and then the system will go and build the code. Can you show me the Antigravity user experience and how this is shown there?
Yeah. One sec. Okay. Can you see the Antigravity screen?
Yep, I can see this.
Architecture.md. So the thing is, Gemini created architecture.md automatically, wherein which in Claude, it presented as a text. I just asked explicitly, can you just go and put this as a .txt file? Then it put it as a TXT file.
Does it have very similar kind of details like Claude has? Is it comprehensive enough for you to verify?
It's like around 120 lines, not super detailed like what Claude does in terms of the file, folder structure and everything. Claude went super nested level, like full details. It split all the folders really well, wherein which Gemini was a bit abstracted. Let's say S3 service, it just kept only S3 service. Wherein which Claude, for download, it was a separate service, upload separate service, parsing logic under a separate service.
What is useful? More details is useful?
Yes, yeah, you're right.
If you ask Gemini if you prompt it to say, hey, you're not giving me enough details, I wanted more detail, will it give?
Yes, it is giving. I tried for a couple of other places, but this is again, it's just a neck-to-neck comparison, apple to apple. I didn't ask anything explicitly to do Claude, so it went to the detail. Here it is a bit abstracted.
Got it. Is this a thing about the model or the agentic system that they've built on top of it? Where do you think is actually the difference? Gravity is the agentic engine built on top of Gemini 3 Pro. Code is the agentic engine built on top of Sonnet 4.5. At least the one you're using is Sonnet 4.5.
Yes.
Where is the difference? Is it the underlying model that's a difference, or is it the agentic system?
It has to be in the model level. I'm not seeing anything. Agent has to do with... Initially, I thought it has to be agent, but it just comes from the model at the end. So I feel...
You're saying if you communicate the intent very clearly to both models, Claude is just much better, more detailed. Exactly. And I know we use Claude heavily, so we are seeing the very similar experience there also. And of course, what is your sense about instruction following? When you're prompting the system to go and iterate on all of that, are both the models very similar in terms of following your instruction, actually giving you what you want?
Almost same. Both they are pretty close to each other, like generally obeys really well.
Okay, so you get this as step one. So you're saying, in Gemini, it's not giving you enough details. In Claude, it's giving you enough detail for you to know that it's covered all the edge cases and all. So what happens next? So you approve this, then?
Yeah. And next step would be like writing code.
Okay.
Generally, it started writing code. I just generally prefer, hey boss, I don't want you go an autonomous way and writing all on your own. You come to me and ask, is this file good? Shall I go on? Likewise, I prefer that each file has to go through my approval. I set the same preference both in the Claude code as well as, so I go read the file. Every time a Python file comes, I'll just skim through it. Okay, looks good, create it. And then pretty much once all the files are done, generally I think through, is there anything still missed? I'll just start with running the code. Then we will realize something, right? In my case, I realized certain pieces I missed. For example, I should have covered how to pull all these secrets. By default, the Claude code written everything with the assumption of everything will be coming from .env. But in my case, it has to come from a secret manager. Right? Then I had to just go prompted, hey, by the way, you need to change this. The config modules where you are pulling certain secrets, connection string and everything has to come from AWS. Then the code change will start happening. Once it starts happening, the good thing is we can ask these models generally, right? Both also play a very similar role here in terms of testing these functions. It could really write a good utility or test cases to test those independent pieces. For example, a particular function's job is go and connect with secret manager and just check the secret manager is able to successfully connect it and able to read the secrets or not, right? I don't need to go and run all my main file to go load every module. This is writing a very smart test case where individual utilities are being tested really well. So we know these utilities are properly tested for these kind of edge cases. When you're assembling together, yes, it all works together well. So
you're saying Claude code is better than Antigravity in that front?
Yes, it was able to test those independent utility really well. I feel Sonnet 4.5 with the Claude code did a better job there actually.
Okay, bulk of the time you're saying the 20 hours is... So talk to me about this, right? You gave this prompt, this plan, it came up in what? In 5 minutes?
Yeah, less than 5 minutes.
Okay. You reviewed it, you took half an hour, 1 hour to review this?
Yeah, half an hour easily.
Let's say 1 hour you took to review this, and then you approve. And from then, how much time before the base code gets generated? How long is that?
Hardly 15-20 minutes max, back and forth, bunch of approvals, all the file. Yeah.
Okay. And in that 20 minutes, also bulk of the time is just approval. Otherwise, if there was no approval, if you just ask the system to generate the code for all of this, it's literally how many tokens and number of tokens per second, right? That's all.
That's it. That's all. Yes.
Okay, got it. So it's probably not even 5 minutes, probably 3 minutes. So with approvals.
Yep.
So in 90 minutes, you get to a base code from that prompt that you gave.
Yep.
And then from here, the remaining 18 hours is just literally iterating, right? Hey, this scenario is missing. This edge case is missing. You could optimize here, all that kind of stuff. Now tell me this, if all those edge cases, if you had already included them in the main prompt itself that you had given, then the number of iterations would have reduced.
Yes, to some extent it would have reduced. But again, one thing I noticed with these models, like both Gemini as well as Claude, it obeys. When I gave, okay, this is what I wanted to process in parallel, when I later checked, it was not parallel. It was still doing sequential because of one of the memory buffer. It just kept things in buffer, due to which it was unable to process really in parallel. It looks like a parallel, but it was not the actual parallel processing, or it was not even doing a disk fill or anything. So it was just kept it in memory. My entire goal is to optimize memory. It followed pretty much a lot of architecture. But later when you tested and came to know, no, it's not a properly memory optimized system. Still there is a loophole. I need to back and forth testing and giving a feedback. Though you are covering all the details, it's all of a sudden like, oh, it could build a production ready application. At least the models are not there yet, honestly.
Got it. So what you're saying is there are very detailed scenarios that it missed. So essentially it introduced bugs in the system because your goal was memory optimized. If it is not memory optimized, it's a bug. So it introduced a bug in the code that you had to manually think through and figure it out. Curious, if you were to go and tell the system, hey, can you look at the code again and verify if all scenarios are covered? Would it have figured it out? Or is that particular scenario that you're talking about is something only a senior developer could have caught?
It figures out certain nuances. For example, in one case, I think models are still capable of figuring that out. I was like, you are making a mistake. Can you go and figure out what's happening? But I explicitly informed the model saying there is a mistake.
Can you specify which mistake? What was the actual issue in the code?
The actual issue was, there is the Python lock, the global lock will be there. You cannot override that lock, which means if there is a CPU intensive operation going in Python, it has to be sequential. There is no way you can do multi-processing while CPU intensive task is going. It didn't even cover. Then it just, when I say mistake, it came up and saying, I attached a log also, by the way. This is a log. That is a mistake. I'm not saying this is a truly parallel or anything. You have to just come back and tell me what's going wrong, where it is going wrong. It was able to capture it. Oh, yeah, my bad. Python has this global lock. We cannot override it, which means it is parallel, but up to this point. From there, it is sequential up to this point. From there, again, it is parallel. It was able to put together all this information and was able to present. But it was not explicitly telling anything.
Is this a case of essentially two things, right? One is limited context, which is obviously this documentation related to CPU log exists somewhere in Python documentation. So the system was not able to connect the dots. That particular scenario could apply here. The model did not connect the dots that, hey, this log is something that will get impacted when you're trying to do parallelism. So that context was not connected, point number one. Number two is the log context was not available, the execution logs, right? I think the first one is more like a model-related thing because it has to figure out some of its global knowledge of Python and how these systems work. I don't know if in the future they can connect the dots at that level. But the second one, what you're saying is more of the execution logs being available, which is not the case here. And hence that context was missing. So in the future, let's take Antigravity. If you are running this on Google Cloud, GCP, maybe it can have access to the execution logs. So essentially the system can be in the future in such a way that, hey, I'm just not going to write the code. With your approval, I'll run it. I check out the logs. Give me some sample data that you will have in your staging system. Let me run it and verify if these things are actually happening, one parallelism and all of that. Because it will not just have your code logs, but it can also have logs to the EC2 or the equivalent machine it's running, machine logs, system logs, operating system level logs. It can check all of that to verify if the execution actually went fine. Basically, if parallelism was even achieved or not, because that was your memory goal, memory optimized parallelism. I think in that sense, if you think about it, Google is positioned much better because they have the best model, at least as good as a model compared to other people. But they also have this cloud product, GCP, so they can combine these two and essentially build a much better coding agent of sorts in the future. Would that be right?
Absolutely. Yeah, you're right.
If I'm not wrong, in Petaview, we are already doing this, right? We already have execution logs as a context that feeds back into the engine to determine if the execution went right or not. It's one of the metrics that we use to determine if something went wrong. Okay, got it. So it's a very important input to the agentic system. Now, would you say that, okay, if these level of kind of automation that I'm talking about were to happen, then this 20 hours can come down further. It could be more like 10, 5 hours.
Exactly.
Would that be the case?
Yeah.
Okay. Another question is, so you approve the plan. The 20 hours is more like iteration and testing and all of that. But the end of 20 hours, you got a solid system. Did you actually go to production at the end of 20 hours?
Yes, it's in production.
Okay.
At the end of that 20th hour, we pushed to production, and it's been like 1 week. It is running in production successfully.
No problem.
We covered all the 8 cases. You noticed the token refresh issue. It just automatically retried, caught it, and then resolved it.
So basically,
and then
when
retried,
Claude
etc.
wrote the code, we wrote the code in such a way that for all of these issues, or with your guidance, obviously, plan B, plan C options were one of the code. So retries and all of that were part of the code. Okay, that's good. And you're not facing the issues that you faced before, the memory bottlenecks,
No, nothing,
all of that.
nothing,
This is very
nothing.
optimized, in your opinion.
Yes.
Got it.
Otherwise,
And-
I need to manually go and pull a bunch of things I need to do. I was able to run more than 5 objects parallelly. I was able to sync at the time, and then it was smooth.
Okay, that's perfect. Tell me, now that you've tested anti-gravity also, would you continue to stick to Claude, or is there a world where you'll switch to anti-gravity?
Again, that's where the personal preference model-wise, both are doing really great. I feel still there is a slight edge or advantage for Sonnet 4.5 with Claude Code. For me, it feels like the experience for a developer. Somehow I feel like I have more control there in terms of the test cases, the way in which written, or the bash command it is coming up with and doing things. And I was telling you another point earlier, right? I experienced it personally between Claude Code and the anti-gravity. The anti-gravity was more like, I need to go and get the things done. The mode will be like, yes, you gave something, let me go through it, think through it. Boom, the direction is go and get the things done. Where in Claude Code, it's more like a kind of my companion or my peer engineer, where it'll have a back and forth conversation, and then it won't just immediately go and start writing. It's more like, what do you think? Shall I go and do it? Or do you see, is there anything else to be covered? I just thought through these. What is missing? Or 3 more options it gives. Do you think anything else to be covered? And there is an alignment once it happened between myself and the model, then it'll start go and write code. The Gemini, the tendency was slightly different that I experienced when I tested this weekend. It was like, there is a conversation happening, but the direction is more like, I need to go and get the things done. I feel personally confident on that alignment system where I know really what that model is thinking, then we'll go and do it.
But how much is the productivity impact difference if you have to estimate? Since Claude is already aligned with your Claude Code, get approval at every step, which means once executed, it's going to be very accurate and aligned with what you want. And basically, post-execution, the amount of work you have to do is less. Yeah. How much of would that be in a productivity difference? If you had to build the same system from scratch in anti-gravity, would it be more like 30, 40 hours instead of 20 hours?
Easily somewhere between 30 to 40% of more time. I'm not
Got
sure
it.
it's going to be double, but at least somewhere between 30 to 40% of the time I'm
Time
seeing,
extra.
at least from the experience or whatever I'm seeing.
Got it. I think this is great. Good feedback. This is state of the art in terms of where Claude Code is. The bottom line here is, hey, we are not yet at a point where you just tell what you want in 3 lines and then you get a full system out.
Not even
Production
closer,
and
actually.
coverage. Not if you want to take things to production and solve real problems. You have to work with the system and you need real engineers. You need a solid developer to understand these edge cases and nuances and work with the system. You're really not able to get someone just out of college or no computer science degree who can actually go and solve these problems. Not even with AI, basically. Cool. So good. Developers still have jobs. Again, the way I think about it is, I was in another podcast. Someone asked me, hey, are analysts going to lose jobs? I said, no, everybody will retain their jobs. They're just going to do 5x more with AI. That will be the expectation, because I think with AI, that's what is going to happen. You're going to become much, much more productive and you're going to do 5x more.
I'll tell a good example, right? While I spent this 20 hours, I encountered a bug where one of the property in Mongo, it was being set. It's supposed to be set as 0, but I thought it's the length of a particular chunk. The number of rows is nothing but an offset. That is, for some reason, I assumed like that. I gave the requirement and it's built. Actually, it worked well according to the logic or the instruction or the requirement that I gave. But in the system, when I went and execute, the data was not even processed by other services. It was skipping from those services. Then later I realized I spent like 1 hour identifying like, hey, why it is that the jobs are not getting processed even after uploading the S3. I was checking, debugging, asking the model to back and forth, checking the logs, etc. It doesn't know what's happening because boss, you gave the requirement, I did everything. Beyond that, if something going in your production wrong, how do I know from sitting in your
Yeah, so
release
as I
code?
said, the one module doesn't have the context of the execution of audio. Though this module is setting something in a database and the other microservice is picking from it. So that context
Exactly.
is missing. That's where
Realized-
human intervention comes.
Exactly. Later, I realized, oh no, it was supposed to be 0 while you're inserting that Mongo document, not the length of that chunk. That business logic I connected later after talking to the engineer actually who are working in that another microservice. Then immediately came back and changed, boom. Thereafter, it was working fine, but it took more than 45 minutes of time for me to investigate. It was working locally and everything, but what's happening wrong? The reason I'm saying this is it's not something, oh, you give everything and then boom, it just works out of the box. No, it still has a dependency with other microservices, other developers, engineers, whatnot. So yes, it's more like a proper alignment, back and forth conversation, interaction has to happen. You should adapt as an engineer. I should adapt to the model's behavior. I cannot expect you have to give everything, right? When things go wrong, you have to be very patient, spend time, and then adapt yourself to the model and then get the job done. And of course, the important point I missed to cover here is the memory, right? Like this cannot continuously happen for 20 hours in one go. There is a model compaction will happen. Your session time will be over. Many things will occur in between. So your job has to take a snapshot of the progress, whatever you have done, put it in your proper memory file, .md file, and etc. So that later you can refer and the model can get a knowledge.
So you're saying session reset happens. What happens because of that? As the model is writing code and you are giving instruction, it cannot just consume all the context and then do it. Can you explain this better? This is a little bit crazy.
See, so what happened is one session in Claude Code, if I'm not wrong, it was like a 4 hours, only so much of token that you can utilize in that 4 hours. Either if you just breach the 4 hours or even before 4 hours, you'll breach the context window, the token limitation of that particular 4 hours. Till then, everything will be in its context. It won't compress any of those contexts, nothing. Whatever you are dealing, however it is handling underneath, everything will be in its context. You can refer all the previous conversations, what I talked before. It can recall all those things. But the moment you are breaching that quota or the session duration, that will be something called the session going to be over, or you are breaching the context window limit, I'm going to do a compaction. So thereafter, all the progress you have done will be compressed, which means not all the details or the nuances going to be covered.
So before that happens, you have to instruct the system what nuances to capture. So it creates a compaction in the way you want. So those details are kind of retained, correct?
Exactly.
That's probably the most difficult thing in this whole thing that you explain. And the behavior is very similar for both Antigravity and Claude, is it?
Yes, pretty much. One behavior I just want to emphasize. In Claude, I had to be a little bit explicit on all these things. Whatever I have done so far, take all these so-and-so information, can you put it in a memory file, .md file? It just put really all good. Wherein which Antigravity, certain things it did automatically. It didn't wait for me to go and tell, okay, go and just put these things in particular document. The model itself sometimes create its own .md file. For example, here we are seeing this implementation plan or the walkthrough.md. I didn't even ask to go on, but it still go and take certain snapshot at what particular point. It's just going and dumping. Wherein which the Claude Code, I had to be a little bit explicit, but it will be like a super detail. It just covers day 1, what are the things we are doing. And then day 2, how many hours you spend. Day 3, what are the debugging, etc. On the session 3, what you have done. What are the different things you retried, error classifications, and what was the learning or the lessons you got from that particular session. It just covers all the nuances. When the session is over, I just shut on my system. When I come back tomorrow, it's going to be a fresh session, so no context, nothing. So the first thing I'm going to ask is go and refer this project memory and a couple of other files. Recall yourself what are the things we have done so far in the project. And then let's start the conversations. I'll just like back and forth probing the model. Okay, tell me what we have done yesterday. Tell me what are the different modules you worked. Tell me what was the bug that we fixed yesterday. So I'll try to probing the model in such a way that it was able to recollect those information from the memory. Then I'll get into the rhythm of writing code for that day.
So what you're saying high level is Gemini is doing a bunch of things autonomously, but it misses the details. But in the case of Claude, you have to prompt it at every step or approve at every step. And that's how it's designed to very keenly look at your instructions and operate. But it goes very detailed. And this detailed nature of Claude is you would rather lean towards it, even though you have to approve a couple of times and prompt a couple of times. You would prefer that because that ensures you are not missing anything. And at the end of it, you will get the outcome that you want, which is very reliable. This is your high-level summary of why you have a preference of one system versus the other. And would you recommend that everybody should think like that? Or do you think it's really personal? And are there cases where someone would prefer Gemini and still come out really well?
It could be probably a personal preference, right? Some people might really want it to be, system has to be a little more abstracted, not super detailed. I mean, what type of a problem statement we are solving, that matters here. If you're really solving a very serious problem, you need to put serious effort and it has to be detailed. It cannot be a magic, right? It has to be in detail. You have to go through, you have to spend time, irrespective of the system.
Those kind of problems that you're solving, you're saying Claude Code is just much better because it gives you enough detail to be very careful the outcome is correct. Okay, super. Thanks, Jared. This was great. Thanks again.
Thanks, Prasanna.